Good day, everyone. I welcome you all, be it a parent or a student. In today's class, we will be considering this topic, the refraction at plane surface. I want to let you all know today that if you are writing or sitting for any examination, no examination board will fail to set question under this topic. Very, very important topic in physics. All right, without wasting much time, let us delve into the topic. First thing we do is that we are going to look at refraction, we define all the parameters, look at refraction, then we'll also look at the ray diagram of refraction. So let's start immediately. So first, what is refraction? By definition, refraction can be defined as the change in the speed and direction of a wave as it crosses one medium to another medium with different density and direction of a wave as it crosses the boundary from one medium to another medium, usually from a less dense medium to a denser medium. Of course, it can be vice versa. Refraction can also occur when wave is traveling from a denser medium to a less dense medium. So it can be of the two ways, either from a less dense medium to a denser medium, or from a denser medium to a less dense medium, as the case may be. So by that definition, we will represent that definition in a diagram. And that diagram is called the ray diagram of refraction at a plane surface. Now, this plane surface is talking about where refraction occurs. And that plane surface is known as the refracting surface. So in the next video, I will be showing you how to draw the diagram of refraction on a plane surface. All right. The first we are going to draw is we are going to draw the plane surface where refraction is going to take place. All right. When you want to draw the ray diagram of refraction or any properties of wave, be it reflection, diffraction, interference, and so on and so forth, make sure that you use your ruler. Very important, because your diagram must be accurate. All right. All right. So here is my refracting surface. Write it there. Refracting surface. Refracting surface. Okay. So now above your refracting surface is where we have the medium one. Don't forget that refraction is talking about wave crossing the boundary from one medium to another medium. So above your refracting surface is your medium one, and below is medium two. Take note of this labeling. So medium one and medium two. Right. So incident wave front, the wave as it's coming from the medium one to as it's getting to the refracting surface to enter the second medium. So we're going to draw a diagram to represent the incident wave front. So we have something like this. All right, this line is called your what? The direction of the what? Incident wave front. So you put your arrow there. So this line here, this line, we label it as what? Direction. That is direction of what? The incidence wavefront. So this is your wavefront. Now, this line that I draw, all this line like this, call them what? Call them the incident wavefront. That's your incident wavefront, right? And this is the direction from medium one. Now, the point where the incident wavefront hits the what? The refracting surface. That point is called incidence point, or the point of incidence. So this point here is called point of incidence. Point of incidence. That is the point. Now, on your point of incidence, you must draw a line called normal. Normal. And what is a normal? A normal is a line that is perpendicular to the refracting surface at the point of what? Incidence. This Darwin diagram is very important. So you label it as normal. Right. Now, between the incident wavefront and the normal, the angle between the incident wavefront and the normal is called angle of incidence. It's called the what? Angle of incidence. So this is the animal. This is the angle that is formed between the incident wavefront and the what? And the normal. Okay, let's move on. Now, from definition of refraction, when a wave is traveling or is crossing the boundary from one medium, so this wave, as it touches the boundary now, is going to what? Refract. It's going to do what? Refract. So you draw your refracted what? Wavefront. That's our refracted wavefront. So this is the direction. So you label it. There's direction of refracted wavefront. Direction of what? Refracted wavefront. So you show your refracted wavefront. So this is the refracted wavefront. Refracted wavefront. Right. Now the line of refracted wavefront and what? The normal. The angle there is known as angle of what? Refraction. So here is angle of refraction. When you are dealing with refraction, these two angles are very important parameters, the angle of incidence and the angle of refraction. So this is medium one. We can call this the air, and we can call this the medium one. We can call it what? Water. That means the wave is coming from what? From air to what? To water. Right. Having done this, of course. Now, one of the things you should know is that in the definition of refraction, we said when wave, the change in the speed. So in the medium one, they have what we call speed, the speed of that wave in medium one. Of course, the wave also has what? A wavelength. So the V1 represents the speed of the wave in what? Medium one, and lambda one represents the what? The wavelength of the wave in medium one. So as it crosses into another medium, the speed will change, and that can be labeled as V2. Of course, the wavelength will also what? Change as what? V2. And that is why we said refraction is defined as the change in the speed and direction of the wave. So this is the speed and this is the wavelength. Speed changes, the direction also changes. All right, don't forget the direction. In the second medium, the refracted wavefront may move close to the normal or bend away from the normal. Of course, if the wave is traveling from less dense medium, air, to a denser medium, water, the refracted wavefront will bend towards the normal. But if reverse is the case, if the wave is traveling from a less dense water to a less denser medium, rather, water to a less dense medium, air, the wavefront here will be moving away from the what? From the normal. Take note of that information. Right. So this is the ray diagram of what? Of refraction occurring at a what? Plane surface. Take note of this diagram, very, very important. So now the next thing we will now consider is what I call the laws of refraction. The what? The laws of refraction. The laws of refraction. So there are two basic laws that you will be asked to state under this. What is law one of refraction? The first law of refraction states that the incident wavefront, the normal, and the refracted wavefront all lies on the same point on the what? On the refracting surface or the boundary. I'll take it again. The first law of refraction states that the angle of the incident wavefront, this line, the normal, and the refracted wavefront all lies at the same point on the what? Plane refracting surface. And that's all for the first law of refraction. Then we'll also move on to second law of refraction. You see, this second law of refraction is also known as Snell's law. You know, every year, exam body in our country usually asks us, whether in the practical or in theory, that we should state Snell's law. And Snell's law is also known as second law of refraction. So Snell's law states that in a given pair of media, that is when a wave is traveling from one medium to another medium, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is what? Is the constant of that what? Pair of media. I'll take it again. Second law of refraction, also known as Snell's law, states that in a given pair of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a what? Is a constant. And that constant is known as the refractive index of the media. Refractive index of the media. So in the next video, I'll be showing you the mathematical relationship of this second law. Okay. So, all right now. Now, according to the second law states that what? The ratio of the sine of angle of incidence to the sine of the angle of what? Refraction is what? Is a constant. And that constant is known as what? Refractive index. That is moving from air to what? To water. From the diagram I showed you before. So now, this the refractive index now in the two medium can be related together with the speed. I want to relate this refractive index with what? The speed, because there must be a change in speed. So refractive index now is equals to the ratio of the what? Of the velocity in medium one, that is V1, that's V1, to the velocity in medium 2. In what? Medium 2. And that is V2. So we can say the refractive index is equals to V1 divided by what? V2. If you recall, the velocity of a wave is given as what? Frequency lambda. That is frequency multiplied by wavelength. Substituting it here, you have the refractive index now of the two medium is equals to velocity in first medium divided by velocity in second medium. Since velocity is frequency lambda, it becomes frequency lambda over frequency lambda. Now, this wavelength will be one in medium one, and here will be the one in medium two. Of course, what happens to the frequency? Don't forget that the frequency of the source of production of the wave is the same thing everywhere. So the frequency in medium one is equal to the frequency in medium two. So frequency will cancel out frequency. So finally, the refractive index now of that two medium one and medium two, is given as what? From Snell's law, sine I divided by sine R is equals to velocity in medium one divided by velocity in medium two is equals to wavelength in medium one divided by wavelength in medium two. So this is the mathematical relation of Snell's law with respect to what? Speed and what? Wavelength. All right, thank you for watching. Don't forget to like and share this video, and also don't forget to follow my Facebook page, TikTok page, YouTube, Instagram. under this video.